skeletal muscle cell is composed of numerous smaller cable-like myofibrils, which in turn are made up of a bundle of parallel myofilaments. Myofilaments are divided into functional units called sarcomeres, in which the actual contraction takes place. The myofilaments come in two flavors, thick and thin. Thick filaments are composed of myosin, while thin filaments contain actin, troponin, and tropomyosin. The interaction of thick and thin filaments is called the cross-bridge cycle and is the driving force behind muscle contraction. When the muscle is relaxed, the golf club-shaped myosin head is bound by ATP and detached from the thin filament. Along the actin fiber, a complex composed of tropomyosin, as well as troponin C, troponin I, and troponin T are in a down position, blocking myosin from binding to the actin. Once the neuromuscular junction has transmitted a signal, calcium concentration in the muscle cell jumps sharply. The troponin complex has 4 calcium binding sites, 2 of which are low affinity sites. Once these 2 are filled, the complex undergoes a conformational change, which moves it up and away. This movement allows tropomyosin to also relocate, clearing the way for myosin to bind. Even with the binding site clear, however, myosin will stay in its detached position if it is still bound by ATP. As the ATP is hydrolyzed to ADP and inorganic phosphate, the myosin head rotates back to its cocked position before jumping to an actin binding site, forming a cross bridge. The actual contraction begins when phosphate dissociates from myosin, triggering the power stroke. The myosin head rotates 45 degrees, pulling the actin along with it. Once the power stroke is finished, ADP leaves, and the cross bridge is stuck in the attached and contracted state. If ATP again binds to the myosin head, then the cycle will start over at the relaxed stage.